Welcome to PPL Navigation and Flight Planning Lesson 1, Part 1. The PPL Navigation exam is by no stretch of the imagination the easiest one out there. It's listed as one of the hardest ones. So what I've done is I've broken this down into lessons and parts of those lessons to allow us to be able to really take on board everything that needs to be covered and give us the time to be able to reference back quickly and truly understand what we're trying to get through here. So let's carry on. The boring bits first, phraseology and terms. There's a lot of phraseology and there's a lot of terms used in the navigation and flight planning, which will then lead on to the various equations and routes for calculations. So it's important that we get the terms and phrases out first. Once we've taken on that, we can start getting into the really cool stuff like the use of the E6B and how we move on from there. So first of all, the axis and direction of the Earth's rotation. The Earth, defined in shape as an oblate spheroid, rotates around the polar axis. The axis going through the true north and true south poles, commonly referred to as the geographic poles. Please remember, everything highlighted in green you really need to take on board. These are the things that will get asked of you moving forward in the exams. When looking down from the North Pole, the Earth is rotating in an anti-clockwise direction from west to east, which is why we see the sun rise in the east. Geographic and magnetic poles. The geographic poles are true north and south and sit vertically, whereas the magnetic poles are where the Earth's magnetic fields or flux enters or exits the Earth. The magnetic poles are not in the same location as the Earth's surface, on the Earth's surface as the geographic poles, and is constantly moving. The equator is defined as an imaginary line on the Earth's surface equidistant from north and south pole that sits perpendicular to the axis of rotation. The equator is a great circle, which by definition is an intersection of a sphere and a plane that passes through the center point of the sphere and divides the sphere in half. On parallels of latitude, the equator is the only great circle, whereas in parallels of in meridians of longitude, they are all great circles. Parallels of latitude are defined as the imaginary lines around the Earth that are parallel to the equator that connect points of equal latitude measured in degrees, minutes and seconds. 1 degree of latitude is equal to roughly 60 nautical miles, and 1 minute is equal to 1 nautical mile. We'll use this a lot later on in flight planning. The equator sits at 0 degrees, and everything north from that increments up to the North Pole, which is 90 degrees, and to the South Pole, which is also 90 degrees. So the way that we define this is an area on the map will either be 15 degrees north or 15 degrees south. Meridians of longitude are defined as the imaginary lines connecting equal points of longitude measured in degrees, minutes and seconds. The Greenwich Meridian, which is also known as the prime meridian, is defined as the meridian that sits at 0 degrees of longitude. Anything west of this increases in degrees west, e.g. west 015 degrees, and anything east also increases in degrees, but will be defined as east 015 degrees, with only the direction indication as the key separator. The prime meridian runs through Greenwich, which is why it's called Greenwich Meridian in the UK, but we will refer to it mostly as the prime meridian going forward. There is also an anti-meridian, which is the complete opposite of the prime meridian and sits at 180 degrees on the opposite side of the Earth to Greenwich. Latitude and longitude is defined as geographical coordinates that enable locations on Earth to be specified using degrees, minutes, and seconds. One of the key things that we will be asked to do within the exam is to be able to identify geographically and through coordinates a precise location. Geographical coordinates that enable locations on Earth to be specified using degrees is given as latitude, degrees, minutes, seconds, and longitude, degrees, minutes, and seconds. It always starts with latitude and finishes with longitude. So, for example, in this particular illustration, A has a position of south 20 degrees 0 minutes 0 seconds and east 100 degrees 0 minutes and 0 seconds. Pause this video and make sure that you can define and articulate the various letters and coordinates on this map. Also try, because a lot of the stuff that we have to do within the exam is guesstimations, and we have to be able to derive from two given indications an approximation between the two. So while B, C and D, F, H give us very precise coordinates, pay particular attention to G, J and I, for example, where you have to make an approximation. Get used to doing this, it will come up a lot in the exam. The direction on Earth is defined as using the 360-degree compass rose method of indicating and to measure direction, referencing our direction from true north as it will be on our VNC charts. So all the lines of longitude on the chart, the VNC or any other charts that we use, even the world charts, the lines of longitude are always based on true north. The definition of the Earth's magnetic field is that the Earth is effectively a large magnet and as such has a magnetic field. A free-floating compass needle is affected by this field, aligning itself to the lines of flux, which is magnetic field lines. The lines are vertical at the poles and horizontal at the equator. The magnetic poles, as we said earlier, are not stationary and move periodically. The magnetic poles are inclined currently at 23.5 degrees from the geographic pole. True north is defined as the place on Earth where the axis of rotation enters the Earth in the northern hemisphere. True south will be the place on Earth where the axis of rotation enters the Earth in the southern hemisphere. Magnetic north is defined as the place on Earth where the lines of magnetic flux enters the Earth in a northern hemisphere. This is where the lines of flux touch the surface at 90 degrees. The definition of compass north is the north direction indicated by the compass, not the same as magnetic north due to errors in the compass caused by manufacturing and electrical and magnetic interference within the aircraft, which is why there is a compass deviation chart in any aircraft cockpit that has a compass. Definition of cardinal directions are the four primary spots that we use every day to indicate north, south, east and west in degrees. Intercardinal directions are the equidistant point between north and east east and south, south and west, west and north. It's very important that we understand and we can quite easily access the degrees for north, east, south and west, and the intercardinal directions. There will be 1 or 2 questions on the exam that come up referencing these. So try them to commit to memory. So northeast 045 degrees, northwest 315 degrees, southeast 135 degrees, southwest 225 degrees. True direction is defined as the direction between 2 points in relation to true north. Magnetic direction is the direction between 2 points in relation to magnetic north, or the direction in degrees true corrected for magnetic variation. And we'll get on to magnetic variation in the next couple of slides. Compass direction is the track measured on our charts corrected for magnetic variation and compass deviation. Compass deviation is in reference to the compass deviation charts in your cockpit that reference the compass that is in that cockpit only. Magnetic variation is defined as the angular difference between true and magnetic north, which changes regularly. An aide-memoire, and one very, very worthwhile committing to memory, is variation east, magnetic least, variation west, magnetic best. We will use these for calculations and jumping between and converting between compass direction, magnetic direction, and true direction. Magnetic dip is not really covered so much in the PPL, but much more in the CPL and the ATPL. But it is important that we can understand what it is. And that definition is the angle between the Earth's surface and the Earth's magnetic field lines. Magnetic field lines are not always parallel to the Earth's surface, which causes the magnetic dip. An isogonal line is a line on a chart that joins areas of equal magnetic variation. If you open up your VNC charts for the North or the South Island, you'll see multiples of these running down the left and the right hand side. These indicate the magnetic variation that we need to take into account when planning flights and using compass direction or true direction, and when we're given various pieces of information of magnetic direction, which we will go through in an example in this particular slide, which will show us how to be able to convert between these. But it is important that we can easily define and access the closest isogonal line to our flight areas. Compass deviation is defined as the difference between what the compass indicates compared to the actual magnetic direction. The compass deviation card within the cockpit of your aircraft will show the deviation corrections. And you can see just an example of a compass deviation card at the bottom. Every one card is only used against the assigned compass that's in your cockpit. Every one can be different depending on the placements and the various electrical and magnetic equipment in the cockpit will have its own very specific deviations. And if you want to see a prime example of what electrical interference or magnetic interference can be caused within the aircraft, just hold up your cans up to the compass or close enough to it and you'll see that it'll go nuts. The compass bearing is the magnetic bearing corrected for compass deviation. Important one to remember, we will be referencing this and you'll be using these terms within the exams. True bearing is the direction of a track between 2 points as measured on a chart and measures true north. Measures against true north. Magnetic bearing is the direction of a track between 2 points corrected for magnetic variation. And this goes back to the east is least, west is best. We will get onto some examples in the next couple of slides. Relative bearing of an object is referenced from the nose of the aircraft. The nose of the aircraft will be referenced as 360 degrees. The tail would then subsequently be 180 degrees. The right wing would be 090 degrees, so on and so forth. The relative bearing using the clock method is defined as using the hours of a clock, 12 being the nose of the aircraft and the tail being referenced as the 6 o'clock position. In addition, you would reference the attitude of the object that you are bearing relative to as being either high, level, or low. High being if you're in a 152 or a 172 above the wing. Low being if you're in a Tomahawk below the wing. Level would be level with your plane of attitude. One of the key things that we're going to need to do is convert between true magnetic and compass direction. And we need to be able to very easily identify what information we're given and be able to convert equally between these. The mnemonic that we've selected to use here, although there are many mnemonics that are used and referenced, this is certainly one of the cleaner ones, is TV men do care. TVMDC. And that converts into true, variation, magnetic, deviation, and compass. The other mnemonic that you need to be able to remember is east is least, west is best. And this doesn't just relate to the conversion between true magnetic and compass directions, but we will use it a lot in many, many ways as we go through this course. So true direction corrected for magnetic variation gives us magnetic direction, which means if we are given a true direction and we need to be able to work from a magnetic direction, we need to be able to correct for magnetic variation. And that's the isogonal lines that we'll pick up off the chart. Magnetic direction is adjusted for magnetic deviation and gives us compass direction. So, should we be working from magnetic direction and we need to get a compass direction, we need to adjust for magnetic deviation. So we need to know the deviation that's listed on the deviation card in the cockpit. To remember which way we apply any deviation or variation, we use the east is least, west is best aide-memoire. So, if you wanted to fly a heading of 180 degrees true, with a variation of 22 degrees west, our magnetic direction equation would be 180 degrees plus 22 degrees gives us 202 magnetic. And the reason for that is 180 degrees plus, because west is best, so we always add. So we're adding 22 degrees west gives us 202 magnetic. With a compass deviation of 3 degrees east, east is least, so we would subtract. What would our compass direction be? Well, the equation that we'd go through is that we have 202 magnetic, which we derived earlier, minus the 3 degrees east gives us 199 degrees compass. 202 minus, because east is least, so we subtract 3 degrees east gives us 199 compass. Now, I hear you ask, what happens if you've got a compass and you need to get to true or magnetic? Maha. We can do the opposite. Same mnemonic, TV men do care translates to true, variation, magnetic, deviation, and compass. Wherever you get the opportunity to, draw the little box at the bottom of the screen. It'll help you remember what we're doing and which direction we're going in. The east is least and west is best is still something that we need to remember, but because the opposite is also true, and as it is opposite, the opposite arithmetic is also true. So, just as before, compass direction adjusted for deviation gives us magnetic direction corrected for variation gives us true direction. So if you wanted to resolve the true heading, but only starting with the compass heading, we do the math again, but in reverse. This time adding east and subtracting west because the opposite rules are applying. We read from left to right, so east is least, west is best is always the key. When we're moving from right to left, we're going in the opposite direction, we're using the opposite rules. So 199 degrees compass with a 3 degrees east deviation. East is normally a subtraction, but because we're working in the opposite direction, it's an addition. So we add 3 degrees east to 199 compass, and that gives us 202 magnetic. Now we have 202 magnetic, and we have a variation of 22 west. West, when moving from left to right, is always an addition, but because we're working in the opposite direction, the opposite rules apply. 22 west is a minus, so we take 22 west from 202 magnetic, gives us 180 degrees true. I know it's going to take a little while, get used to it. The way that it works for me is I work from left to right with east is least, west is best, and always using the mnemonic, TV men do care. During the exam, you're given pencil and paper. Whenever you get a question where you have to be able to at least coordinate where everything you're working from is either in true, magnetic, or compass, you will need to be able to convert a compass heading, a magnetic bearing, or a true direction from your VNC charts. The first thing you need to do is make sure that you're working from everything that is the same. So you'll need to be able to convert compass to true, true to magnetic, and once you've got everything together and you're working from everything either true, either magnetic, or either compass, you're working on the same plane. So jump on, do the revision questions and answers. There's quite a few questions around that particular subject, as well as just testing what we can remember. Do the questions. Once you get to the point of getting 100% right, you've nailed the process by which we calculate. Let's move on to lesson 1, part 2. But do the Q&A. Best of luck.